Day 1, Problem 1. Part A. Rewrite the number into standard form. 9.3 times 10 to the negative 1 power. Let's start by writing that down. And then consider what it would mean to have the number 9.3 and to multiply it by 10 to the negative 1 power. The meaning of a negative exponent is to create a fraction. 10 to the negative 1 power means 1 over 10 to the first power, or just the fraction 1/10. And if you have a number like 9.3 and multiply it by the fraction 1/10, it's going to create an answer that is 1/10 as much as 9.3. And that number would be a smaller number than 9.3. It would be 0.93. So multiplying by 10 raised to some negative exponent has the effect of changing the decimal, or moving the decimal point one position to the left. And that would create the number 0.93. Now part B. Rewrite the number into scientific notation. The number is 0.08. And I want to write this in scientific notation. And I want to be careful this time because I recall the last time I had a warm-up in which there was a small decimal number less than 1 and I changed to scientific notation. The first time I did it, I made the exponent on the 10 positive, and then I had to go back and edit my video and fix that. So let's be a little more careful this time on whether the exponent on the 10 is positive or negative. To change a number to scientific notation, we want to have the decimal point so that there is one non-zero number to the left of the decimal point. That means we need to move the dot here so that the number 8 ends up left of the decimal point. That's going to involve moving the decimal 2 spots. And that will create 8 point, and now the times 10. Okay, let's carefully think through the exponent on this 10 so that we don't mess it up this time. Okay. We moved it 2 spots, so it's certainly going to involve a 2, but is it a positive 2 or is it a negative 2? Okay. If it was a positive 2, that would be like having 8 times 10 squared, or 8 times 100. Well, that's 800. That is not what this number is. We need to have this as a negative 2 on the 10. Now, day 1, problem 2. Solve this equation and then check your solution. So in part A, let's write out that equation. And then isolate the letter A by removing all of the other numbers that are on the same side of the equation as the A. Now I notice that the A term is grouped inside of parentheses, and that outside of the parentheses there is the number 1/2 being multiplied to that group. Before we can get the letter A alone, we first need to remove the 1/2 to get the group alone, and then we can continue from there. So one way to remove the fraction 1/2, which is being multiplied to something, is to multiply by the reciprocal of 1/2. And so on the left side of the equation, I'm going to multiply by 2. Or another way to think of 2 is 2 over 1, the reciprocal of 1/2. And then multiply by 2 on the other side of the equation. The reason for doing that is because the 2 and the 2 cross-cancel. Similarly, the 1 and the 1 you could think of as cross-canceling. And this just creates one of this group. It's like getting the group alone. And so we can write the 8a minus 6. And then over here, 17 times 2 is 34. Now here's the A term. We can remove the number next to it by adding 6 to both sides of the equation. The 8a comes downwards, and 34 plus 6 is 40. 8 times a is equal to 40. We can remove the 8 times by dividing by 8 on both sides of the equation. 8 divided by 8 makes 1a, and that is equal to 5. Or another way to say that is a is equal to 5. Now in part B, let's check whether 5 is the right answer for A. So write the original equation down, and when we come across the A, let's substitute in a 5. If we simplify this expression and it turns out to be 17, then we know we have the right answer. So let's work within this set of grouping symbols first. 8 times 5 is 40, and 40 subtract 6 makes 34. Then, what is 1/2 times 34? Well, half of 34 is 17. And so 17 is equal to 17. This checks, and that means that A equals 5 is the correct solution for A.